All right, physics students, today I'm going to do homework page 103, 1 through 4, and this is on relative motion. And so this takes some of our vector information and it applies it to things like velocity and displacement. Today it's mostly on velocity, but what happens when you have vectors, velocity vectors that are working together or working apart or working at weird angles? So number one, a passenger at the rear of a train traveling at 15 meters per second relative to Earth throws a baseball with a speed of 15 meters per second in the direction opposite the motion of the train. What is the velocity of the baseball relative to Earth as it leaves the thrower's hand? So imagine you're standing on some sort of flatbed train car here, right? And the train is, hooked up to some, old-timey locomotive, right? And anyway, the train is moving 15 meters per second, we'll say, to the right. Okay, now you're standing on the train and you are going to throw it this way at 15 meters per second. All right, so the question is, what is the velocity of the baseball relative to Earth as it leaves the thrower's hand? So what we do is we have two vectors, and if you wanted to, you can make an XY axis for this one. I don't think you really need to, but I take one vector, let's call it vector A. Let's call this one vector B. So I have one vector here, 15, and then the other vector is going to add on, but we start that one at the head of this one and bring it back to here. So that's 15. Really a number line, I guess, would have made more sense than an XY axis, but the point is the displacement of that ball is 0. Okay, because 15 minus 15, this is a negative 15 because it's going to the left, equals 0. And there's actually a really good Mythbusters YouTube, it's like a minute long, of them shooting a cannon off a moving truck and showing that it doesn't go anywhere. It's really pretty cool. I'll actually probably show you that one in class. All right, number 2. A spy runs from the front to the back of an aircraft carrier at a velocity of 3.5 meters per second. If the aircraft carrier is moving forward at 18 meters per second, how fast does the spy appear to be running when viewed by an observer on a nearby stationary submarine? And he's running at 3.5 meters per second. Sorry. And the aircraft carrier itself is traveling at 18 meters per second. All right, I should probably make this vector much longer just because it's, 5 times the speed, okay, or 5 times the velocity. So again, this is a situation where we're not dealing in 2 dimensions. It's pretty easy. I can take one vector, 18, and then the 3.5 is coming back this direction. And so what is my resultant vector? My resultant vector goes from where I start to where I finish. So someone watching from the side would see him still moving to the right because his resultant velocity is going to be 18 minus 3.5, and that's going to be 14.5 meters per second. Okay, so if I'm at the side here and I see this aircraft carrier off in the distance and I see this guy moving according to the ship, he's still going to be moving that direction because the ship is moving that way. All right, number 3. A ferry is crossing a river. If the ferry is headed due north with a speed of 2.5 meters per second relative to the water, and the river's velocity is 3 meters per second to the east, what will the boat's velocity relative to Earth be? All right, so here's our river. And here's the ferry. And it's traveling this direction. A bunch of cars on here. All right, and it's traveling at 2.5 meters per second north. All right, and the water on this river is flowing 3 meters per second to the east. All right, and so what's going to happen to this ferry as it travels, right? Well, it's trying to go north, but it's also moving to the right. So in actuality, it's going to end up moving somehow in this direction. So how do we show that? Well, we take the two vectors, we take our 3, and then we add it to the 2.5, which starts here. And it doesn't really matter the order. I could have started with 2.5 and then gone with 3. Regardless, I still start here and end here. So this is, I'm going to get the same resultant vector either way, right? So let me just redraw this here so that it's a little neater. 3 meters per second, 2.5 meters per second. This is the resultant. All right, well, that's a right triangle. So to find that resultant, let's call it C. We just use the Pythagorean theorem. So C squared equals 3 squared plus 2.5 squared. Take the square root of both sides. So 3 squared plus 2.5 squared equals, take the square root of that. I get 3.9 meters per second. All right. And the other question though is, what is the angle? It says, what's the velocity? So this is our speed. And for velocity, we also need a direction. So if I look at this triangle, I have the opposite and the adjacent side. That's tangent. So if I go tangent of theta equals 2.5 over 3, and then take the inverse tangent of both sides. Tangent crosses out inverse tangent, and then I go inverse tangent of 2.5 divided by 3 equals 39.8 degrees. Let's just call it 40 degrees, and so my angle here, theta, equals 40 degrees. So that is the vector, that's this right here. So it won't be going 2.5 north, it won't be going 3 meters per second east, it's going to be moving 3.9 meters per second, almost 4 meters per second at a 40-degree angle. So it's not going to get to where it's going unless it planned on getting here and then purposely tried that, going that direction. Okay, that brings us finally to number 4. Number 4, a pet store supply truck moves at 25 meters per second north along a highway. So here is my truck. I guess it's some kind of semi maybe. And it's moving 25 meters per second north. And inside there's a dog that moves at 1.75 meters per second at an angle of 35 degrees east of north. So this is north, this is east. So 35 degrees east of north would be here, and that's a 1.75 meter per second value. All right, so I need to combine these two and to know what the dog's velocity is. So let me pull those out. So here's my 25 meter per second truck motion. I'm going to take this here and put it up here. I'm going to draw it a little out of scale just because it's kind of hard to make that true to scale. And so I'm going to draw my resultant connecting here. That's going to be the velocity of the dog, v. Okay, So this is a straight up and down line, whether or not it looks like one or not. This angle is 35 degrees. Okay, so what I need to do is I need to break these vectors into components. And I'm going to make an XY axis here. So this is going to be my x-axis. The y-axis is right here. Okay, so he's traveling right up the y-axis, then there's a little bit of a push this direction. The dog's vector is right here. And so I'm going to pull the dog's vector out. I know this is 1.75. And I can get there in two ways. I can go up and over or over and up. And so I'm just going to go up and over. I know that this angle again is 35 degrees. I know this is a right triangle. So this is going to be a little bit weird because this is, let's call this vector B. I'm going to call this bx, and this is going to be by. Now here's the thing. In this case, because the bx is the opposite side of the 35 degree angle, bx will equal b sine theta. In other words, 1.75 times the sine of 35. So I pull this out. And I get 1. Okay, by is going to be b cosine theta because by is the adjacent side to this angle here. All right, now typically x goes with cosine, y goes with sine, but it doesn't have to. But that's the way we usually try to make it. I could have drawn this a different way, which might have made that a little more apparent. But 1.75 cosine 35. 1.43. All right, let's take a look at vector A, which would be just the 25 degrees north, or 25 meters per second north. So that's going this way. Well, that's all in the y direction. There is no a direction, or x direction. So it's ax equals 0, ay is 25 meters per second. There's no triangle I can draw there to make sense of that. So then the last piece here would be this vector here. This is vector v. This is the actual velocity the dog has, and this is going to be vx and vy. So let's pull that triangle out. So we don't know this angle, but we do know that Vx equals Ax plus Bx. Ax we said was 0, Bx is 1, so that's going to be 0 plus 1. Vy equals Ay plus By. It's going to be 25 meters per second plus 1.43. That'll be 26.43 meters per second. Okay, this is 1. All right, so using the Pythagorean theorem, we know that v squared equals vx squared plus vy squared. And I take the square root of both, and this is going to be 26.43 squared plus 1 squared. I got those backwards, but it doesn't matter. And plug these numbers in. $699, take the square root of that. I get 26.44. So almost exactly the same size as the forward velocity. As far as the angle goes, I have 26.4 and 1. Let's use inverse tangent. So theta equals the inverse tangent of 26.43 over 1. And I get 87.8 degrees. So this is my velocity. All right, that's it.